Okay, so a software development project has 4 phases, and here each phase has a month to complete and is estimated to cost $10,000. So fortunately, all the zeros, no letters, and the phases are planned to be completed one after the other. So kind of a waterfall type of thing. And given the project's status at the end of 3 months, calculate the current value of the cost variance, schedule variance, the cost performance index, and the schedule performance index. So basically what we have here is the requirements definition completed, and they spent $10,000. So that's right on. And then the architecture and design started in month 2 but didn't finish till month 3 and spent $12,000. And then the development and unit testing started in month 3 and is partially complete. So if we go across, we see that it's 50% done, and they've spent $9,000. And so again, we can see they've got a problem because they're halfway done and they've spent 90% of the money. And then the system testing go live hasn't started yet. So, and this is the status at the end of 3 months, so system testing go live should not have started. So how would we calculate this?
Oh, okay, that's a good question. Okay, month 1, start time, finish, complete, spent 10,000. We know our budget for the phase was 10,000. So that was our budget. Yeah. We know that our cost was 10,000. I mean, I'm looking at
yeah. So let's look at our let's look at our earned value maybe first.
What was that?
Okay, so if we wanted to look at our earned value first,
I would go B minus AC because that's my earned value. I mean, no, that's my my cost variance, the EV minus the AC. That's not my estimated.
Well, I'm thinking, let's try to get all our numbers here. So our earned value, the requirements definition task earned $10,000, right? Because it was a $10,000 task and it's complete.
Yes.
And the architecture and design, that also earned $10,000 because it's complete. And the development and unit test is 50% done, so that's earned $5,000, right? So our earned value right now is $25,000, correct?
That's right.
Okay, and then our, let's go with our actual cost. So our actual cost is what we've spent so far. So that's 10 and 12 and 9, which is $31,000, right?
Technically, we're only at 3 phases at this moment, so it should be 30,000 because
it should be 30,000, but we've spent 31 because we've spent 10,000 on the first, 12,000 on the second, 9,000 on the third so far. And then our and our planned value, because it was supposed to be 10,000 per phase, is 30,000. So we've got PV of 30,000, we've got EV of 25,000, and we've got AC of 31,000. So what is our cost variance?
Oh, okay. Well, we know what it is. I mean, we definitely know that it's $1,000. But you want to know exactly what we're going to use to determine that.
Yeah, so what's our cost variance?
Okay, so
EV of 30, and we had AC of 31, and we have EV of 25, then what's our CV?
Oh, that's right. So it's the 25,031. 25,000 is our earned value.
Uh-huh.
So it's our EV. Aren't we going to do our EV minus our AC?
Yes.
which is our 25,000 minus the 31. We know it's $6,000.
Right. And even worse, it's negative $6,000.
Oh, yeah.
So that means the project is over budget by that much.
That's
and
right.
what would be our schedule variance?
Okay, our scheduled variance.
Uh-huh.
Okay. So that's our earned value, which is our 25,000
Uh-huh.
minus our plan value.
Yes.
Our plan value is supposed to be 30,000.
Right.
So we know that we're negative 5,000.
Right. So right now we're over budget and we're behind schedule. So what's our cost performance index?
Okay. So that's our earned value, which is our 25,000 minus our, isn't my earned value?
Yeah, your earned value is always first.
Oh, okay. And then I have to divide that by my actual value to get my percentage.
Right. Okay, so now here's another part of that example. So now that you've calculated the CPI,
Okay.
then calculating the EAC with just the CPI, what would you do?
Okay, let's say, based on the CPI, which is 1.12, and a budget at completion of 200,000. What is the estimate at completion? I mean, that makes sense.
Uh-huh. So,
It's
so basically, you've got the budget to complete and you've got the CPI. So that would be, the estimate at complete would now be 178,571.
So that's our estimate to complete that. Could you leave that slide?
Sure.
I haven't done these, oh my goodness, in such a long time. They're a lot of fun, actually, because they're calculations.
Oh yeah, because and this is really a good part of the test, you know, for you to power through. And you know, once you set your budget for time per question, hopefully you can blaze through these questions at a really good rate.
I used to have to do all these when I was in school, and I don't get to do any of this anymore because I'm technically only helping from the strategic end rather than specifically where the cost is. I'm just going, this is what we need to do, this is what needs. So I think this is so much more fun because you're doing calculations, they're concrete.
Right.
Hold on. Okay.
Okay. Okay, now yet another extension of that example. How would you calculate the estimate to complete? And again, remember, because estimate at complete and estimate to complete are fairly similar in terminology, make sure that you understand which one the question is asking for on the PMP exam.
Well, you're taking your estimate to complete or your estimate at completion, and you're doing it minus your actual costs.
Right.
And our actual costs were the $57,850.
Uh-huh.
And then our estimate at completion was the $178,571, and you're just subtracting to get the difference.
Correct. And so the difference there It's done for us. There's 120,721. Okay, now what about schedule performance?
All right, throw another monkey wrench in this. Let's see, the SPI is calculated as the earned value divided by the planned value. So our earned value was that was the 65,000 rather than the actual of 57. So that was the earned. So the, let's see, earned
Yes,
was,
the earned value was the 65. And now we know the planned value was 60. So doing that division
comes to the, 1.08. Let's see, understand what his project is tracking against the schedule after the first month of work. Plan value was 60. Okay, so provided that, so the plan value, I mean, it's pretty straightforward. It's pretty simple.
Yeah.
So, yeah, it's pretty simple when the value is already put there. John is managing a 3-month project. He's working. John wants to see if the positive SPI of the project will.
So here, if we were going to take into account cost and schedule performance indices, because we think that both of those will be reflected in the forward-looking costs, then we get 169,438 and some change. So basically,
so we took the actual value.
Yeah, so here we took the actual cost, which was the 57,850 that we've already incurred.
We took the estimate at completion.
Yeah, and then we took the budget to complete, which was 200,000, and the estimate of complete, which was 65, and divided that by the fact that we're really getting more bang for our buck. We're getting $1.12 for every dollar put in, and we're getting an hour 0.08 for every hour applied. So basically, we're going to come in at only 169,438.69 instead of 200,000.
Okay, so that's our estimate at completion that will come in.
Right. So that's obviously that's a good thing because we had two numbers bigger than one there in the denominator.
Okay. Earned value. It's interesting. All of it, how it all.
So there's a lot of good ways, and a lot of good information here to do calculations. So to just kind of roll up this section, let's talk about some of the key terms. Obviously, the more you put into something, the less you get out of it. So, if you double the number of resources on a project, you won't necessarily take the time in half because, like when I was talking about painting and carpeting, if two people have to exist in the same space, that just won't work. Plus the fact that you'll increase the lines of communication, which we'll talk about later. So you never get one for one, adding will get the job done. Or, the old putting 9 women on a baby for a month will not get you a baby at the end, at the end of a month. So again, working capital is the amount of money the company has to invest on the project and day-to-day company operations. So what do you think about working capital? Do you think that's an EEF or do you think that's an OPA?
Or an OTA.
OPA. Organizational process asset or an enterprise environmental factor?
It's an OPA.
Actually, working capital is considered an enterprise environmental factor because
why?
Any particular project can't affect the overall working capital for the company. At any given time, I mean, granted, once they finish the project or, they blow the project or something, but the amount of working capital is kind of a given and that's an external resource. So just.
Oh, is that what it's really? And I think of it as it's an asset once I have it.
It is an asset and it is something the company has, but it is not affected by the project manager or the project management office. So from the project management office and the project manager viewpoint, it's an external.
Oh, I see what you're saying. Okay. All right.
So just like just like a tool that you pick, say if you picked Microsoft Project as your scheduling tool, granted you get to pick it, and maybe the project management office gets to pick it, but once it's picked, it's an enterprise environmental factor, because you're not going to tell Bill Gates, oh, I want this changed. Or at any rate, okay, so some more key terms, depreciation, and of course, I'm sure you understand with your corporate assets.
Yes.
Good items purchased lose value over time, and so cars and computers pretty much fall off the edge of the earth, and at the beginning, and then after 3 years are virtually worth nothing. So PMI might ask you about two different kinds of depreciation. One would be a straight line depreciation, where say you lose on a car $1,000 a year for every year for 10 years, which obviously for a car that's not really true, because you drive it off the lot. You drive it off the lot if you could find a $10,000 car that would actually drive off the lot.
Yes.
You would certainly find that after the first year you'd lose more than that. But straight line is basically the same amount of depreciation across the whole life of the thing, where each year you lose 1/n of that. So if you're depreciating over 5 years, you'd lose 1/5. If you're depreciating over 20 years, you lose 1/20. But basically, that's the idea of straight line depreciation. And then there's also various kinds of accelerated depreciation, because in reality, a $10,000 car, if it ran, would depreciate $3,000 when you drove it off the lot, never mind the first year, and then $1,500 the second year, and $1,000 the third year, and so on. So there are various kinds of accelerated depreciation, and you probably don't have to do any of those, like double declining sum of the digits sort of things. But if you did, you would just have to know the difference between, straight line depreciation is just the same amount every year, and accelerated depreciation is a different amount, which gets smaller necessarily every year, and that basically you're depreciating things down to zero. And
Yep.
so those are the fundamental takeaways from PMI.
Never used accelerated.
Huh?
Never, ever have I used accelerated. I'm not even sure why, but never used it.
And I was going to say, yeah, there's a couple, three, different ways to calculate the accelerated kinds of depreciation. But again, they're not going to ask you to do that. They're just going to want you to know the difference when they explain a scenario and say, maybe, is this straight line or is this accelerated? Or if they gave you a scenario and said, here's the thing, and it's kind of, it's a technology thing like a phone. Do you think that, not that they'll ask, do you think, but you might have to assume that that would be an accelerated depreciation, because let's face it, after 2 years, the phone battery is pretty much shot. So you probably wouldn't want to straight line depreciate that, because you lose a whole lot more at the beginning than you do at the end.